Good morning to you all.
Good morning, ma'am.
Right. So yesterday evening we had introduction to the probability. On that we introduced new concepts and some terms related to probability. That one is first, we started with the definition of the concept probability, and then we introduced about how the probability are assigning to the events on simple events. It was based on the random experiment and their outcomes and the sample space, then how we can derive the sample space for a random experiment. And from the random experiment, when we create the sample space, then how we can assign probabilities to those all simple events. There are three approaches we learned. One is the classical approach. Under the classical approach, we are making some assumptions. Mostly, we are making the assumptions all the simple events equally likely chance to occur. And then we had a approach, relative frequency approach. On that, we repeated the experimentation several times under the same conditions, or we collected some information regarding the historical data. Then based on that, we are calculating, we can get the frequency table, and from that we can calculate the relative frequency. That relative frequency we are taking as the probability for each and every simple event in the particular given random experiment. Right. So far we learned about how we can assign a probability to the outcomes or simple events obtained from the random experiment. Right. Now we are going to calculate the probabilities for the event. So now you know the difference between the simple event and the event. Simple event are the outcomes. So we cannot further decompose it. Right? That is a simple event. So for the simple, to calculate the probabilities for the simple event, we have to assign the probability using one of the approach, relative frequency approach or classical approach. Then the event means they are the combinations of two or more events. Combinations of two or more events. So for that, how now we can calculate the probability. So because that event is made up of several simple events, these simple events are mutually exclusive. That means two cannot occur at the same time. So that means we can add the probabilities. At the probabilities of the simple events, which are the simple events used to make that event. So for that event, we can add the probabilities of those simple events. So example, now we are our random experiment is rolling a die. So here we assume that it's a fair die. So here the meaning it's a fair die means each and every outcome on the die is, on the simple event obtained from rolling a die is equal. Right. Now can you write the sample space for this simple event? Put in the chat box. Sample space of the experiment rolling a die. It is a 6-sided die. So write the sample space. Yes, 1, 2, 3, 4, 5, 6. Right. Now what are the probabilities of those simple events? Quickly write the probabilities of those simple events. Here now we can have the what is called for each and every outcome has 1/6. It's a fair die and 6-sided die. So under the classical approach, we can assume that each and every outcome has equal chance to occur. so that there are 6 outcomes. So each and every outcome, the probability of each and every outcome is 1 over 6. Because the total probability should be 1. So the 1 is the total probability. That's divided by 6 for each and every outcome. And each and every outcome's probability also in between 0 to 1. Right? So now here, this is the sample space for this one. So P1 equals P2 equals P3 up to P6 is equal to 1 over 6. So now we are defining the event A, that is getting an even number. So what is the probability of getting an even number? First, you have to find out what are the simple events used to make this event. So even number. So there are 6 possible outcomes for rolling a die. So in that, what are the even numbers? Even numbers mean it's divided by 2. So 2, 4, 6. So getting an even number is probability of A. So now we know that these 3 simple outcomes are mutually exclusive. That means they cannot occur at the same time. Because it's a sample space, we are creating the sample space on that condition. So now we can write probability of A is equal to, because these are the mutually exclusive, that is probability of 2 plus probability of 4 plus probability of 6. So that is 1 over 6 each and every. So 3 times we are adding 1 over 6, that equals half, that is 50%. So what is the interpretation of this one? There is a 50% of chance to get an even number. Or the probability, that is a 60%, 50% chance. Or 50% of likelihood to get an even number when rolling a die. Right? So that is a very basic example. Now there are various methods to determine the probabilities of the events that result for combining other events in the various way. Now here, the previous slide, we look at how we can calculate the probabilities for an event that is made of with the simple events. Right? The event that is made of with simple events. Now we are extending the events which are combined more than one event, which are combined more than using the more than one events. Right? So how we can make, first, what are the methods are available to combine the events? One is the so the types of combinations and relationships between the events. Now we are taking, there are 2 events A and B. And first combination, it's made of a complement of an event. If you know the event, and then what is a complement of an event? That means the event which does not occur. If A is an event, then A complement of A, one Right. Types of combinations and the relationships between the events. First one, we are taking the complement of an event, right? That means if we are taking a complement of an event, that means does not occur, right? That will be denoted by A bar or AC. Another combination of two events, that is intersection of two events. That means both events occur at the same time, right? Both events occur at the same time. So that is intersection of two events is denoted by A and B or A intersection B. This is the mathematical notation. Otherwise, we can write it as A and B. That means it is a joint event, right? So two events can occur at the same time. Then union of two events. This is also, we can combine two events. We can combine two events used as a intersection or union. It is either one of the events or both events can occur. Either one or both can occur. Here only both. A and B, only both will occur. Here one or both. Either one or both will occur. That is A or B or A union B. So these are the combinations here we are going to use to calculate the probabilities. Right. So if A and B are two events, then probability of A or B, that is probability of A union B, that is equal to probability of A occur or B occur or both. Right? A occur or B occur or both. That is probability of A union B. Then A and B, that is probability of A intersection B. So that is also probability of A and B both occur. Then probability of A complement, that is denoted by, this is also same notation we can. That means probability A does not occur. We have to calculate the probability that A does not occur. Then it is another combination A given B. That is here, this event already occurred. If it's occurred, then what is the probability of A? That is a conditional probability. Little later we will learn about this one. So this is also one of the combination of two events, right? Then probability of A occurs given that B has occurred. Right. Now we are taking this example for the combination of those events, right? So now here we are taking the same example, the number of spots turning up when a six-sided die is tossed, that is observed. Now consider the following events. Now we are taking A defined as the event A, the number observed is at most 2. So here the meaning you have to understand. Then we can find out how this event is made of with the outcomes of this random experiment. So the number observed is at most 2 means the maximum number we observed is 2 or below 2. That is the meaning of at most 2. 2 or below 2. Then the number observed is an even number. This is we looked at this example in the previous example. Then number 4 turns up, just number 4. These are the 3 events. Which events are made up of with this simple events. Right, now here we are creating some of the questions based on this random experiment. First, you have to define the sample space for this experiment and assign the probabilities to the simple events. This is the first step. After that only you can calculate all those probabilities, right? So now we go one by one. So we know that this is a very simple example. So the sample space is 1, 2, 3, 4, 5, 6, right? So assuming all these simple events are equally likely. Otherwise, we cannot assign the probabilities for those simple events. So here we make an assumption. It is a die. So here classical approach we can apply. So we assume that all simple events are equally likely. Right. Then based on this classical approach, the probabilities for the simple events are each and every simple event has equal chance. Accordingly, it is 1 over 6. Now we have to find out for the first question, this is your part A answer. Then part B, find probability of A. So now what are the simple events we have to define the event A? So what is event A? That is the number observed is at most 2. So now I told that at most 2 means we can observe the numbers 2 or below 2. So what is 2 and below 2? Only 1 and 2. So A is made of 1 and 2. Right? So these are two simple events which are mutually exclusive. These two events cannot occur at the same time. So probability of A is equal to probability of 1 plus probability of 2. Here we have what is probability of 1, what is probability of 2. So that is 1 over 3. Then probability of A complement. What is probability of A complement? We know that A complement, first you have to define the simple, what are the simple events for A complement. But we know the meaning A complement, that is A does not occur. A does not occur. So now to occur A, the simple events for A is 1, 2. So what are the, from this sample space, what are the rest of the elements? 3, 4, 5, 6. So these simple events 3, 4, 5, 6 are belonging to complement A. So now we find out what are the simple events are using to make A complement. So accordingly, the meaning of A complement in which A does not occur. So the elements that are not belonging to A, the elements which are not belonging to A is 3, 4, 5, 6. Then here, these also simple events which are mutually exclusive. So probability of A complement is equal to 4 over 6. That is 2 over 3. So probability of A complement is 1 minus probability of A. That is 2 over 3. Right? Then C, that is fourth part, are the events A and C mutually exclusive. Here, this is not actually based on this one. Whether now we find out A and C are mutually exclusive. So if you want to find out A and C are mutually exclusive, now we have to look at what are the simple events belonging to A and C. So if it's a mutually exclusive, what is the meaning of mutually exclusive? Both events does not occur at the same time. So if both events does not occur at the same time, there is no common elements belonging to both events. Right? So now, so we have to know what are the elements belonging to A and C. Already we defined A is 1, 2. And what is C? C, the number 4 turns up. So there is only one element, 4. So now these are the possible simple events to make A and C. So C is 4 and A is 1, 2. So now if you're looking at A and C, there is no any common element. So entirely C is 4 and A is 1, 2. So these two events cannot occur at the same time. So A and C not, because there is, if there are some common elements, then we can't say that. But here there is no any common element for both A and C. So A and C do not occur at the same time. Therefore, we can say that A and C are mutually exclusive. Right? Then part E, find probability of A or C. So now we are looking at what is A or C. That is either A or C or both can occur. So now first we have to find out what are the possible simple events which are belonging to A or C. So that is A or C, we can write in such manner A or C. Now A is 1, 2, C is 4. Accordingly, the concept or the definition of A union C, either A or C or both. So there is no any common element. So all three elements will come. So 1, 2, 4. Now these 1 to 4 are mutually exclusive. So we can add those probabilities to get the probability of A union C. That is P1 plus P2 plus P4. That is 1 over 2. Right? Right. Then A and B. Find probability of A and B. So first we have to look at what are the simple events which are belonging to A and B. So for that, we have to consider the simple events for A, that is 1, 2, and for B, that is 2, 4, 6. So A and B that occur at the same time. That should be, there is a common element in A and B. So here, what is the common element? Here's 2, here also 2. So only A and B consist of the common element 2. So then probability of A intersection B is probability of 2, that is 1 over 6. Right? So if you want more explanation on this, then you can read the material, reading material. I uploaded in the, that is from the starting class, I was uploaded that one. I uploaded that one. So from that you can get you can use the set diagrams also. By using that one, you can get the explanation on further explanation. But this is, I think, because this A union C, A complete, A intersection union and everything, you learn in the O-level mathematics also, right? Right. So now this is as an exercise, right? So this is the first exercise. Now here up to this, what are the exercises I am leaving? Then you have to complete all the exercises and you have to upload the answers by taking the scan or by scan the document and take it as a one PDF file, all the exercises I am leaving today. Then you have to upload that answer in the create folder will be created there with the take-home assignment. And that you have to upload the answer on or before Monday midnight. Monday midnight. Then when you are coming to the Tuesday physical class, you have to bring your answers and then we will have some discussion on those answers, right? So if you are not coming with those answers and the understanding, then you will have to go out from the class, right? So the Tuesday is a discussion on those questions, Tuesday morning class, right? The physical. So before that, each and every student must upload the answers on the folder, which folder will close on midnight, Monday midnight, 12 o'clock. Okay. So this is first exercise. Already these slides also uploaded, right? So this is the first exercise. And this is the second exercise, right? Right. Now another concept, conditional probability. That is already we learned with a combination. Conditional event mean the effect of the occurrence of A will be affected by the occurrence of B. So here we know the previous partial knowledge. We know this already occurred. So if this occurred, then how this event, whether this event A will be affected by the occurrence of B. So if B occurred, then what about the occurrence of A? So the probability of occurrence of A is depending on the probability of occurrence B, right? So the probability of an event when the partial knowledge about the outcome of an experiment is known, called the conditional probability. So we use the notation probability of by how we are reading A, this vertical line given A given B. So how we are writing the conditional probability that if the event A occurs or event A occurs, given that B has occurred. Now you look at the grammar. Here present perfect has occurred, then it's happening. If this event is occurred, then what is the probability of occurrence of event A? So the partial knowledge is contained in the condition probability of A given B. That is probability of A and B divided by probability of B. Right? So the partial knowledge is contained in the condition. Right? Right. Now here we are looking at the example. Here there are four, here it is a cross tabulation or contingency table, right? So here there are following table. It compares the mutual fund performance against the ranking of the school where the fund managers earned their MBA. Education and the performance, business performance and the educations are compared here. So there are four events we define. A1, fund manager graduated from a top 20 MBA program, right? A1 is the fund manager. This fund manager is graduated from the top 20 MBA program. So that is the probabilities here, this one. 0.11, because if B1 is the outperforming the market and B2 not outperform the market. And A2 did not graduate. Each one, if a B1 is outperformed, B2 not outperformed. These B1 and B2 are the complement events. Similarly, A1 and A2 are the complement events. Right? Here graduated from the top 20. Not graduated from the top 20. Right? Then this 0.11. That means there is a 11% of chance that the manager outperforming if he is graduated from the top 20 MBA. Right? 0.11 means there is a 11% of chance outperforming the business with a graduation from the top 20. This is 0.29 chance, right? B2 not outperforming the market with a graduation from top 20. This means there is a 6% of chance to perform better or outperforming the stock market or mutual fund performance without graduation from the top 20. Here the 0.54 means there is 54% of chance not outperforming the market without graduations from the top 20. So here A1 and B1 occurred at the same time. Here that means performing the market with graduation from the top 20. Here not performing the market with graduation from the top 20. Right? Similarly, these are the four probabilities. Now, you have to calculate the probability that a fund will outperform the market. A fund will outperform the market given that the manager graduated from a top 20 MBA program. Given that the manager graduated from a top 20 MBA program. Right? So the answer is, now here we are writing probability of, now here you look at how we have to choose where the already occurred event and which one is the happening event. So now this term, given that, now you have to find the probability that the fund will outperform. How the fund will outperforming is denoted by B1. Fund outperforms the market. So that one will come, B1. Then given that the manager graduated, here it is a occurred. It is a going to occur. It is occurred. Right? So that is here. A1. The manager graduated from a top 20. Fund manager graduated from a top 20 is given by A. Right? So you have to calculate the probability of B1 given A1. So already the previous slide, we have the formula, that is probability of B1 intersection A1 given that probability of A1. It is a joint probability. Both occurred at the same time, graduated, and it's going to happen. This one, A1 intersection B1 is this one, 0.11 plus probability of A1 outperforming the market. Outperforming the market. There are two. Either one, this one also outperforming the market. Given that manager graduated, right? Fund manager graduated from the top 20. So here, these two are. Here also graduated from the top 20. For this, not outperforming also graduated. So this is occurred already. So to find out the fund manager graduated from top 20, you have to add these two probabilities, either this one or this one. There is no any condition for that one. So 0.11 plus 0.29. That is 0.275. That is 27.5%. So what is the meaning? There is a 27.5% of chance or likelihood that the fund will outperform, or the mutual market will outperform if the manager is graduated from the top 20. If the manager is graduated from the top 20, the probability of outperforming the fund market is 27.5%. Right? So now so far we calculate the probability, then random experiment, sample space, simple event and the event. Approaches to assign the probability to the outcomes of random experiment, computing the probability of events, then computing the probability of combination of events. Here we looking at the combination, complement, union, intersection, conditional. Right. Now another type of combination, independent and the dependent events. So what is two events, A and B, are said to be independent? That means the occurrence of the occurrence of one of the events does not affect the occurrence of the other event. Right? So that means if two events are independent, then probability of A given B equals PA. So if conditional means if the B occurred, it will affect A, then probability of A given B. But when we are calculating the probability of A given B, that is same as probability of A. So that means the B does not affect A. Right? Or probability of B given A. The other way, probability of B given A equals PB. Either one of is appropriate if the two events are said to be independent. Right? So if B is not affected, then probability of A given B is always same as probability of A. So if probability of A given B not equal to probability of A, the events are dependent. If both are different, right, then two events are dependent. So in the independent, if the occurrence of the one event does not change the likelihood of the occurrence of the other event, then these two events are independent, right? And also you have to note that it is very important. Don't confuse with the independent and the mutually exclusive. Both are not same. Independent, the occurrence of one event does not affect the occurrence of the other event, right? But mutually exclusive, both events do not occur at the same time. Both events do not occur at the same times. That means there is no any common element belonging to both events. There is no any common element which are belonging to both events. This is the difference between the independent and the mutually exclusive. So from those explanations, now you have to know that clearly you are able to distinguish the difference between the independent and the mutually exclusive with the suitable examples, right? Now here we are again looking at the marginal probabilities, right? The same example here we are taking. A1 is the fund manager graduated from the top, not graduated, outperforming the market, not outperforming the market. Now here, this 0.4, what is that 0.4 means? Probability that the fund manager graduated from the top 20, that is 40%. There is a 40% of chance that the fund manager graduated from top 20. It is called the row-wise marginal probability. Then 0.6, that is 60%. That means the probability that the fund manager not graduated from the market. So that is there is a 60% chance that the fund manager not graduated from the top 20 MBA program. This is also row-wise marginal probability. Then when we are looking at the column probability, there are two marginal probabilities, 0.17 and 0.83. What is 0.17? There is 70% of chance that the mutual market fund outperforms, right? The fund outperforming the market. So B1 means the mutual funds outperforming the market. The probability is 17%. Here, the 83% of chance that the market of mutual fund not outperforming, right? So when we are adding the marginal probabilities, row marginal probabilities and the column marginal probabilities, you will get 1. This is the row marginal probability, you get 1. It is a column marginal probability, you will get 1 because based on the total probabilities, the total probability. So this is one of the sample space. Performing graduation from the top 20, not graduated from the top 20. This is another one. Outperforming the market, not outperforming the market. So there are two type of sample spaces are there, right? Then these are the combinations, A1, B1. It is A1 intersection B2. It is A2 intersection B1. It is A2 intersection B2. So by row wise or column wise, the marginal probabilities is 1. So if they are asking what is the probability a fund manager is not from a top school. So this row indicates the probability that a fund manager is not from a top school. So that is 0.6. There is a 60% of likelihood that a fund manager is not from a top school. So when we are asking the interpretation, you have to use the simple words, chance or likelihood or possibility. So sometimes the probability non-technical people or non-professional people cannot understand probability. So when we are writing the interpretation in the simple terms, likelihood or chance or possibility, you have to use that word for making the interpretation, right? Similarly, what is the probability a fund outperforms the market? So outperforming the market is denoted by this one. There is two possibilities. When the manager is not graduated from the top 20 and when manager is graduated from the top 20 school, that is 0.17. So there is a 70% of chance that a fund outperforms the market. So both margins when we are adding, that is equals 1. So this is the way of calculating the probabilities and the interpretation using the contingency table or cross-tabulate table. Then when we are looking at using the same example, whether B1 and A1 are independent. Now we are looking at whether B1 means fund outperforming the market. A1 means fund graduated from the top 20. Whether these two events are independent, outperforming the market and graduated from the top 20 are independent or dependent. So now we already know that if we want to look at these two are independent, probability of one conditional probability we have to consider, and also we have to take the total probability, right? So already we calculated probability of B1 given A1 in the previous example, 0.275. That means if the manager is graduated from the top 20, the probability that the fund market will outperform it, that is 27.5%. Then also, if B1 and A1 are independent, we need this probability of B1. So what is the probability of B1? That is fund outperforming the market. Right? The fund outperforming the market is 0.17. So now you look at these two probabilities. It is 0.275. It is 0.17. So since these two events probabilities are not equal, they are not equal. So we can say that these two are not independent. That means they are dependent. So the manager graduated from the top 20 school, the graduations of the manager will affect the performance of the mutual market. Graduations of the manager will affect the performance of the mutual fund market. So that means these B1 and A1 are dependent. Graduations and the outperforming the performance of the market and the graduations of the type of school is dependent. Both are dependent, right? So the probability of B1 is affected by the occurrence of the event A1, right? So this is your third exercise. Based on the previous explanation, now you have to complete this question, right? This is fourth exercise. Right. Now, some of the rules we are going to introduce to calculate the probability of more complex events, right? Now, we're looking at the sample space, outcomes of the sample space, and the probability of the simple outcomes based on the probability of the events using the simple events occurrences, and then probability of combination of two events, that is also using the outcomes of the simple events. Now here more complicated events we are looking at to calculate the probability for the simple events. The complement rule, a multiplication rule, and the addition rule. If events are not mutually exclusive, if events are not independent, then how we can calculate? For the complement rule, already we learned that, right? That is, if the events does not occur. So the complement rule is probability of A complement is 1 minus probability of A. If A means probability of A knows, then you can calculate the probability of A complement. So the complement rule gives us the probability of an event not occurring, right? Then multiplication rule. Here we are going to apply this multiplication rule to calculate the joint probability of the two events. It is based on the formula for conditional probability defined earlier, right? So probability of A given B is equal to probability of A and B, which is divided by probability of B. Right? If then when we are multiplying cross multiplication, then we know that probability of A and B, this is a joint probability that equals probability of A given into PB. If A and B are independent, Otherwise, sometimes if A occurred earlier, then probability of A and B is always equal to probability of B given A into probability of A. This is depending on whether we have to put A given B or B given A. That is depending on the occurring of one of the, which event occurred earlier. Then that will come here, right? If B occurred earlier, then we have to use A given B. If A occurred earlier, then we have to use B given A. So if B is there, then probability of B. If A is there, then probability of A. It is depending on the occurrence, but the formula is similar. If A and B are independent, then probability of A given B is equal to PA and probability of B given is equal to PB. So that is, if A and B are independent, then for the joint probability, you can get by multiplying the probability of A and the probability of B, right? So this is one of the rule, multiplication rule. So using the multiplication rule, here we have one example. In this example, it is a graduate statistics course. There are 10 students. Out of 10 students, 7 students are male and 3 students are female. Now, the professor wants to select 2 students at random, right? He wants to pick up 2 students at random to help her to conduct a research project, right? So, what is the probability that the 2 students chosen are female? What is the probability that the 2 students chosen are female? So here, both are female. So that is a and. First student also female and the second student also female. That's a joint probability. Both are female. So we are putting as a F1 intersection F2 or F into F. So now, according to this formulas, we can use this one. Right? So now it is a first selection. Probability of the first student is being female. So what is the probability that first student being female? That is, there are 3 female students out of 10. So here we are applying the classical rule. Each and every selection of student has equal chance. So 3 over 10. Because there are 3 female, then 3 over 10. So if the first student is being selected, then what is the probability of selecting the second student also female? That is probability of F given F. Now here only 9 students. Already 1 student is selected. So there are 2 female students. So the probability of selecting 1 student out of 9 is 2 over 9. So the probability of getting both female students is 6 over 90. Then if you want to interpret, you have to make it as a percentage. Then there is that kind of percentage is there to select or to pick up 2 female students for the research project. Right? So here we are applying this conditional probability rule. So the second selection is depending on the first selection. Right? Now we are looking at the addition rule. So addition rule means we are want to calculate the probability of event which occur A or B or both occurring. Right? That is, we want to calculate the probability of union of A and B. So that is probability of A or B, that is probability of A union B, that you can write it as PA plus PB minus probability of A intersection B. Now you look at this. This is the Venn diagram using the set theory. So here it is an event A and this is another event B. So there is sometimes these 2 events will be intersected. That means some common elements also belonging to there. So this shaded area is A intersection B. A is full green circle and B is this orange. But if there are common elements, then these two events will mix up. This part is called the intersection part. That's denoted by A intersection B. So this A intersections B having the common elements which are belonging to A and B. So in that case, probability of A union B, this total probability you have to calculate. This green shaded, this magenta shaded, this orange shaded, both probabilities calculate. So we are taking, this is probability of A that we can calculate, then probability of B, but 2 times occurred this one. A also covering this part, B also covering this part. So or 1 time we have to subtract probability of A intersection B. So minus probability of A intersection B. So when we are subtracting 1 time, then this will same as, right? Okay. So probability of A union B is equal to PA plus BB minus PA intersection B. Right. Addition rule for mutually exclusive. So if A and B are mutually exclusive, that means there is no common element. So these two sets are not joint. These two are disjoint events. These two are disjoint events. They are not happen at the same time. So in that case, there is no common element A intersection B. So that means it is a empty set. A intersection B will be empty set. So probability of, if there is no elements, then probability of A intersection B will be 0. Right? So if A and B are mutually exclusive, then the occurrence of the event that one event makes the other event one impossible. That means 2 events does not occur. This means that A intersection B is an empty set. So probability of A intersection B is equal to 0. So if the addition rule for mutually exclusive, probability of A union B is equal to probability of A plus probability of B. Right? So now there are 3 rules we learned. One is the A complement, that is 1 minus probability of A. If conditional, probability of A given B is equal to probability of A intersection B over probability of B. If independent, probability of A intersection B is equal to probability of A into probability of B. And for A union B, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. And if it's mutually exclusive, then probability of A union B is equal to probability of A plus probability of B. Right. Now here we are having another example. There are 2 newspapers which are published in a large city, which are naming as Sun and Post. The circulation departments report that there is a 20% of chance that the city's household have a subscription to the Sun paper. There are 22% of the subscribers are there for the Sun papers, and there are 35% of subscribers are there the Post paper, and also 6% of the households are subscribing to both Sun and the Post. So now you have to calculate what proportion of the city's households subscribe to the either newspaper, not both, to either. So from this wording, you can find out we have to calculate the S union P, SOP. Either one of SOP. So SOP will denoted by SUP. So now first we are defining what is S. S is the event subscribing Sun newspaper. P is the event subscribing Post newspaper. So now we have to calculate probability of subscribing to either newspaper. That is probability of S union P. That is probability of S using the addition rule plus P minus probability of S intersection B. All the probabilities are here. Probability of S 22%, 0.22. Probability of S 35%, 0.35. And both subscriptions, 6% of the households, 0.06. That is 0.51. So there is a 51% of chance that the household will subscribe either one of the newspaper, or 51% of the subscribers are there, either one of the paper they are subscribing, right? And this is the fifth example, exercise, right? This is the fifth exercise. This is also you have to complete and you have to submit your answer. Right? Then decision trees. We can use in some cases when the two events are occurred, then we can apply the decision trees with a conditional or not conditional. We are calculating the probabilities. Both events should occur using the more than one event. Okay, we can use the probability tree, which is a simple and effective method, right? So the same graduation method here, selection method we are going to apply for the research team. Right. So now, already we learned that example, a graduate statistic course has 7 male and 3 female students, right? The professor wants to select 2 students at random to help her to conduct a research project. So what is the probability that the 2 chosen events were female? Right? So now, first selection. So what is the probability of selecting a first female student? 3/10. Similarly, if we are selecting a male student as a first, then 7/10. Then second selection. So there is also, we can select either female or either male. Now, the second selection is depending on this selection. Now here only 9 students. For the second selection, there are 9 students. So here this selection is depending on the first selection. If first female student is selected, then selecting the second student, 2/9. If the first student is female, but second selection is male, there are 7 students. So 7/9. Right? Similarly, if the second student is female, when the male student, after the selection of male student, then there are 3 females, so 3/9. Now here, second also male and first also male, then there are 6 male students. So out of 9, there is a 6/9. This is a method of constructing the probability tree. By using this one, then easily you can calculate the probabilities, right? Now we are extending this one. So at the end of the branches, we can calculate the joint probability, right? So this means both selections are female. So 3/10 into 2/9. F and F both are female. This branch N indicates first is female, second is male. That is 3/10 into 7/9. Right? So this branch indicates first male and the second female. So that is 7/10 into 3/9. Then both are male students. That is 7/10 into 6/9. Right? Right. This is, I think, next exercise. Right? Using the probability trees, tree diagram, you have to calculate the required probability. This is another exercise. Right? You have to calculate the probability using the tree diagram. And here, all those are the exercises, right? So in this, there are nearly, I think, 10 exercises are there. So what are the, for which questions there are no answers? You have to complete all those questions and then scan the document as a one PDF document. All the answers should be, you have to write the answers in the papers. And then all the answers should be scanned and you have to convert as a one PDF document. And then you have to upload that one PDF document in the folder created for this take-home assignment, right? So the folder will be, I think, I will name it as a probability assignment of probability, assignment for probability. Right? So that folder, you have to submit your answers on or before Monday midnight. On or before Monday midnight. Right? Then for the Tuesday morning, all students must be ready with your answers and you have to bring your answers. What are the answers you submitted on the folder? With that answers, you have to come to the class. Then all these exercises will be discussed. Okay. So now we completed the basic and the Tuesday discussion class, and then Wednesday class, we will start the new section, random variable and the probability distribution, that with the physical. Anything you want to ask me? So nearly 5 weeks we have more to complete your semester, right? So now we will move little bit fast, right? So similarly, one examples I will explain. Then all other exercises we will leave as a homework. Then you have to prepare the answers and submit the answers in the LMS. Then after submitting the answers, then we will have a discussion on it. That this pattern we will have in the physical class. Right? So all the exercises we are leaving as exercises, then we will have a discussion on during the class time. So if you are bringing the answers, then only it will be fruitful for you also to get the understanding. Right? So then also you have to note that answers and then you can learn it, and also you can understand where you are leaving the mistakes. So, and also the students with the answers only will admit the class, physical class. Otherwise, you cannot come to the physical class. Right? Now all the classes will be in the physical format. So now here you look at, even with the Zoom, there is only 147 students. Nearly more than 100 students are absent to the class. Right? So even in the physical class, if you are not preparing for learning and not completing your homework assignments, then don't come to the physical class. Right? So who are interested in studies, then you can join with a physical class. Otherwise not. Mainly for the discussion class. Right. There are nearly 267 students submitted the which one? Mind map diagram. Most of the students I selected randomly some mind map diagrams. Averagely, you did the mind map diagram. That mind map diagram also, I bring one of the discussion class. I brought that, I will bring that mind map diagram and then explain that one, right? So here also the homework, all the homework assignments will be marked. But for the physical class, for the 267, this diagram, also you have to bring it. So who are the students bringing with answers for the discussion class? Only those the answers will be marked, assignments will be marked. Even in the mind map diagram, first mind map diagram and the probability assignment questions, right? Based on your physical attendance with the answers and your performance. Based on that one, those homework assignments will be marked, right? Otherwise, you will not get the marks, right? So that discussion class will make more time. But anyway, if you want to get the good experience with the discussions, you have to bring with the answers. And based on that one, based on your attendance, then I will select those answers and I will mark it. Okay. So next Tuesday, we will meet with physical. Any other doubts you want to ask me, then you can clear on it now. Otherwise, we can close the meeting. Right. So now I'm ending my meeting. So we will meet on Tuesday physically.